This presentation on patterns of existence and my separate artist talk on passeggiata are interlinked. Each helps to explain and act as the corollary of the other. By tracing a pattern of commonality between all the activities I've engaged in during a long life, I can claim that patterns and pattern making have been a crucial part of my engagement with design, architecture, science, art, and most recently visual music. I'll be including just a few snatches of my visual music in this presentation. I've now realized that the weaving of patterns, the interpretation of patterns, the recognition of patterns, and the analysis of patterns are all pivotal in providing a common thread linking both natural events and all forms of human enterprise. At the cosmic level, order or pattern occurs as the result of the unexpected triumph of natural selection, acting not alone, but together with the emergence over billions of years of self-organized systems. Such systems spontaneously generate much of the order of the natural world. It is only then that selection comes into play, further molding and refining. The fact that it is twin sources of pattern-making order, and not a single source, that have produced not only us, but also everything we experience that surrounds us, changes our perspective on recent discoveries. In the early 1950s, when on the day they first perceived the double helix of DNA, Watson and Crick announced to astonished drinkers in a Cambridge lunchtime pub that they'd solved the mystery of life. This was at most a half-truth. They had indeed found an undergirding pattern, which impacted directly on processes of natural selection, but the realization came only later that their uncovering of the geometry by which chromosomes are arranged in the nucleus of every living cell was just one of two sources of life in the biosphere. My own foray into systems of self-organization was prompted by Turing patterns, which for me have always been a constant source of fascination. Alan Turing's The Chemical Basis of Morphogenesis explains not only how tigers got their stripes, but also provides the scientific explanation for the spontaneous miracle of development before birth. It's a theory that underpins Stuart Kauffman's view that the range of spontaneous order in the biosphere is enormously greater than is often supposed. In my piece of visual music, Turinga I celebrated Turing's prescience by perturbing one of his patterns, a hexagonal spot pattern. You'll have seen in that short excerpt an extraordinary diversity of forms emerging seemingly spontaneously from my image sequences. It seems that in Turinga I discovered a purposeful tool for simulating natural processes. After I completed the piece, I got to know Professor Jeremy Green. He's that rare exception, a biologist who has fully embraced the concept of self-organization in regulatory networks occurring in tandem with the chance outcomes of Darwinian selection. He gave me some insight into how Turing's work on morphogenesis was just part of his search for the mathematical basis of how we think, how human intellectual abilities can be replicated using artificial neural networks. Little did Jeremy know at the time that it was his comments on Turinga that set me off on a subsequent search into the patterns that underlie how our brains work. Years earlier, I'd met Igor Alexander, Professor of Neural Engineering at Imperial College London, who regarded the brain as being dependent on an unexplored form of engineering, one inspired and controlled by an astonishingly intricate structure or architecture. These twin influences from the realms of biology and engineering set me on course to explore for myself the astonishingly intricate pattern that underlies our ability to think. To find the clue to the neural pattern of connections hidden within the human brain, I turned to Islamic geometry. Islamic designs can not only confound the eye of the beholder with their complexity, but also they can provide a geometric clue to solving complex spatial problems. An examination of Muslim buildings in Istanbul, Afghanistan, India, and elsewhere reveals patterns based on the knitting together of complex, identical geometric forms. The result is a network where the lines of the mathematical scheme can be regarded as systems of neural communication. By taking a very small section of the brain as an example, we can begin to see a pattern producing a multitude of ribbons that interweave one with another in designs of dazzling complexity. Of course, this is not what we see when presented with the brain's grey matter. This is why, in a piece of visual music called Brain and Mind, I attempt to show the brain's billions of nerve cells entering into a coherent system of activation. A system which, in spite of appearances, is still determined by a precise Islamic pattern. Of course, all of that was a conjecture, a shot in the dark in defining our brain's geometry. But Jeremy liked the Islamic parallel. He saw it more as posing a question than a model of what might actually exist in reality, if only we could see it. How many neurons does a given neuron actually connect with locally? He posited the idea that if the answer were known, you could envisage a variety of textures that might vary across different brain regions. So there would need to be more than one pattern type. Clearly, my patternist conjecture was not a conclusion, but potentially just another step towards making the invisible visible. This explanation of patterns as a means of discovering order in apparently random systems cannot be complete without now turning to a subject that has acted as a lifelong corollary of my life as a patternist, that is, music. You've already seen a few short clips of my visual music. All my pieces involve processes of pattern creation generated not only by what our brain's visual systems enable us to see, but also by what our brain's auditory systems enable us to hear. All my visual music pieces are concerned in finding order from the twin sources of sight and sound. It's through these two systems that our brain's pathways and neural mechanisms enable us to make sense of the world around us. Visual music is just one outcome of this biological phenomenon, which I'll now explain further with reference to my latest piece, Passeggiata. Passeggiata is a visual interpretation of Luciano Berio's Sequenza 9A for solo clarinet, an exercise in musical discovery that has required me to dig deep in finding visual imagery that seeks to enter the mind of the composer. I've used visual patterns to train deep dream images that are given free rein in providing a visual interpretation of Berio's moments of surprise, when he weaves fast and furious note patterns which collapse the piece at intervals into radically disordered and chaotic states. I'm not showing the results here, but you can experience them in a separate artist talk that acts as a corollary to this presentation on patterns of existence. Please join me for this talk. It will contain a lengthy excerpt from Passeggiata. Thank you for watching and listening.